Hello everyone, welcome back to my YouTube channel. So in this video, let us start with a concept called equivalent circuit diagram of single phase transformer. So without wasting time now, you can see the equivalent circuit diagram. The term equivalent circuit of a machine means it is a combination of fixed and variable resistances and reactances which exactly simulate the performance and working of the machine. It is nothing but. So if you want to draw equivalent circuit diagram, so it is having a combination of resistive drop and reactive drop. Okay, so that you can see for transformer, if we are having a no load transformer, it is having a no load primary current as I explained in a previous video. It is having two components. One is IM, that is nothing but magnetizing component, which is responsible to produce alternating flux, and it is given by I naught sine phi naught. Similarly, one more is active component. You can also call this as core loss component. It is responsible to produce iron loss or core loss. It is given by I naught cos phi naught. So you can see a no load equivalent circuit. It is having a V1 and no load primary current, and it is having a two components. You can see IC. It is responsible to produce core loss, means where there is a resistance there is a loss, so that will be having a resistance R naught. Is responsible to produce core loss. Where there is a reactance there is a flux winding, so that you can see X naught, it is responsible to produce alternating flux. So this is a no load equivalent circuit. So here you can see R naught is given by a simple Ohm's law you are applying. R is given by V by I. Voltage across R naught is V1. Current flows to this is IC. So that R naught is given by V1 divided by IC. Similarly, X naught, which is given by V1 divided by IM. This is given by voltage drop across this is V1. Current flows to this is IC. Similarly, voltage across X naught is V1. Current flows to this is IM. That's why these are the equations. So when the load which is connected now, so whatever you are saying, this is for no load. Suppose if there is a load, so if there is a load means a secondary current which starts to flow. That is I2 is started to flowing through the load, and this causes voltage drop across R2 and X2. The notations I explained in a previous video. R2 is nothing but secondary winding resistance, secondary winding reactance. So that will be produced as a drop because of I2, that is current flows to the load or else secondary winding. So hence if there is a load current means there is a additional current that drop from the primary winding, that is I2 dash. So that if there is a load, primary current or else a primary winding that draws an additional current, that is nothing but I2 dash. So that I explained in a previous video. You know that N2 into I2 is given by N1 into I2 dash, that is additional current. So that I2 dash is given by N2 divided by N1 into I2, that is nothing but K into I2. You can see I2 dash is I2 divided by K. So now I1 is a phasor addition of the load current or is a primary current. This also I explained. So I1 is given by no load current plus additional current, that is I2 dash. Whereas I2 dash is antiphase of I2. Okay, so that is what they are explaining here. So you can see, but in the equivalent circuit, windings are not shown. It is further simplified by transforming or is transferring all the values to primary or secondary. This makes the transformer calculation much easier. Means that windings, you are not showing the windings. You can see this is your circuit diagram or else a circuit representation of transformer. You can see this part is primary side, this part is secondary side. R1 X1, that is a primary side. I1, which is having a no load component, that is I naught plus I2 dash is nothing but your I1. Okay, so that you can see equivalent circuit of the transformer it is. So now we are simplifying this. For that, You'll be having two cases. Either this primary, you need to remove this winding. So to remove this winding, either this circuit we should refer primary winding, or else it should refer secondary winding. Any one winding it should have refer, so that it will be having the two cases. The first case is the circuit which refer to primary winding. So if it has to refer primary winding, means all the secondary, all the secondary parameters, that's nothing but R2, X2, Z2, that you should write in the form of primary. Okay, that is R2 dash, X2 dash, Z2 dash. That is nothing but refer to primary. You can see R2 dash is given by R2 divided by K square. K is a transformation ratio. You know that K is N2 by N1. X2 dash you can rewrite, or else transferring these secondary parameters into primary for writing the equivalent circuit diagram in the form of primary. So these are the equations. Similarly, you can see while transforming, you should remember this rule, that is a low winding or else a low voltage winding which is always having high current and low impedance, and the high voltage or else HV winding which will be always having a low current and high impedance. So now we can observe the circuit. See the winding which is removed. Where there is a R2, there I am writing R2 dash, X2 dash, ZL dash. What is R2 here? R2 divided by K square. This is a transferred value. Okay. E2 dash is nothing but a reflection of E1. R2 dash is a reflection of R1. X2 dash is a reflection of X1. That is why you written here. R2 dash is R2 by K square. X2 dash is by X2 by K square, like that. Okay. So now once after referring this, so next refer to secondary, means here a secondary parameters you are writing in the form of primary by using R2 dash, X2 dash. Next R2 and X2 and Z2 you should have to keep as it is. The primary parameters you need to write in the form of secondary. That is nothing but equivalent circuit referred to secondary. Similarly, all the primary values can be referred to secondary. We can obtain the equivalent circuit referred to secondary. You can see. So there you are representing R2 dash, X2 dash, Z2 dash. Here you are representing R1 dash, X1 dash, Z1 dash. So these equations which will comes in a basics, kindly refer basic textbooks. So K square into X R1, K square into X1, K is a transformation ratio. Then the primary side, you can see instead of R1 you are writing R1 dash, instead of X1 you are writing X1 dash, R0 dash, X0 dash, everything which will be writing a dash on the primary side, because that will be referring to secondary parameters. So next, similarly, the exciting circuit parameters, that is R0, X0 dash, you can see. So, so now we got two circuits. One is which is referred to primary winding, other one is which is referred to secondary winding. So now you need to get some approximate equivalent circuit diagram. So to get the approximate equivalent circuit, shift the no load branch containing R0 and X0. You can see R0 and X0. This you need to shift in the left side. Okay. So that is what they are explaining. Shift the parameters R0 and X0 to the left of R1 and X1. You can see by the left of, you are shifting this to the left of R1, X1. By doing this, what you're doing will be, we are creating an error that a drop across R1 and X1 due to I0 is neglected. Means that R1 X1 drop, R1 due to that no load drop, whatever the error that will be produced, that will be neglecting. Hence, such equivalent circuit we can call that as approximate equivalent circuit. We can see here the definition. That is, to get approximate equivalent circuit, shift the no load branch containing R0 and X0 to the left of R1 and X1. By doing this, we are creating an error that the drop across R1 and X1 that will be produced due to I0 is neglected. That is, no load drop is neglected. You can see you are shifting. Earlier the R0 X0 will be here. Okay, it is referred to primary. So it is shifting to left of the R1 and X1. You can just take the screenshot if you want. Okay. So now you are rewriting here R1 plus R2 dash. These two are in series. You are writing it as R1E. These two are in series. You are writing it as X1E. You can see here the circuit, the approximate equivalent circuit. So R1E, X1E, Z1E. 1E is represents refer to primary winding. The resistance of a transformer that refers to primary winding. R1E is considering of R1 plus, you can see R1 plus R2 dash. If you are writing in the form of 2E, if you are writing R2E, how will write R2E? R2E is nothing but R2 plus R1 dash, R2E. The equivalent circuit which refer to primary winding is nothing but 1E. If it is referred to secondary winding, that is nothing but 2E. So totally how much circuits you need to write in examination? In examination, the first is for no load, you need to write the first circuit and refer the main equivalent circuit diagram you need to write the second circuit, refer to primary third, refer to secondary fourth, approximate two. Total 6 circuits you need to write. If there is a less of explanation, that is also fine, but you need to write the circuit diagram neatly and you have to write the notations for this. So if you're having any doubts regarding this, feel free to write in the comment box. Thank you so much for watching this video. Kindly subscribe, share maximum. And if you're having any doubts, feel free to write in the comment box. Thank you. Have a nice day.